if you're joining us, I'm just giving everyone a few minutes to hop on and making sure all the technology is working correctly. So just bear with me for another minute or so and we'll get started. Just giving everyone another minute or so. All right, let's see, we've got a couple of people in. Hi, welcome. We're going to start here in about 30 seconds or even less. Okay, I show we're right on time, so I'm going to go ahead and get started. For those of you who don't know me, I'm Dr. Christy Mulkey, and I'm the workshop coordinator with 240 Tutoring. And I'm here today to do a live video to help you with the GK Math. And we're doing these videos, or I am, every Tuesday. So same time, 11 o'clock Central Time, but 12 o'clock in Florida, if you're further into Florida. So hopefully you're able to join us. If not, if you can't join us live, this video will stay right here in this Facebook group. So you can watch it later. If you want to watch it again, maybe to catch something you missed, feel free to watch this video anytime you need. But I will be here every Tuesday morning to help you best prepare for your exam. Today we're looking at math, but we'll be looking at some other subjects as we progress over the next several months. So I'm glad to have you here with me this morning, and we're going to get started. So I'm going to share my screen with you, so bear with me for just a second. Right, you should now be seeing my PowerPoint. I'm going to open that up full screen so it's easier for you to follow along. Okay, so again, we're looking at the GK Math, that general knowledge math test. And today we're going to be looking at competency 2, the first 3 skills. Okay, so again, if you have a question, if you have a comment, drop it right in there. If you want to comment and just say, hi, I'm here, that would be great. Love to hear from you. If there's a question you have along the way, put it in the comments. I've got something right here so I can check those as we go. Now, the structure of all of these videos is to try to be specific to your state and your test. And we're going to talk through those competencies and standards. And then I'm going to actually go through some practice questions to teach you some strategy, some skills, and provide some explanation. So if we're looking at the math exam, your math is broken into 4 different competencies. And we are looking at competency 2. Now, if you're like, what about competency 1? That was last week. So go back and check out our video, excuse me, from last week to see review and practice on competency 1. Now today, I'm going to split up competency 2 because this one has a lot in it. And this one is on knowledge of geometry and measurement. Today, we're just going to look at these first 3 skills. Next week, we're going to look at this 4th one. And the reason being, the 4th one actually has some very difficult questions. And I want to take time to walk you through those really well and help you understand how to solve them. So when you encounter more problems like that, you're prepared. I can't do that in a 30-minute video along with the questions that go with these. So we're going to look at these today. It says identify and classify simple 2- and 3-dimensional figures according to mathematical properties. So we're going to be identifying and classifying. Then it says solve problems involving ratio and proportion, including things like scale drawings, models, and real-world scenarios. And then determine an appropriate measurement unit and form, it's like scientific notation, for real-world problems involving length, area, volume, or mass. So that's what we're going to be looking at today. All right, let's jump right into some practice questions. Now, all of these practice questions are the free and public questions provided by Florida on the FTCE website. So if you want to go check that out, there's the website down there really small, or you can just Google it and it'll pop right up. But we're going to look at all the questions that I'm going to walk you through that have to do with those first three skills in competency 2. So question number 7, it says, a building 51 feet tall casts a shadow 48 feet long. Simultaneously, a nearby statue casts a shadow of 16 feet. How tall is the statue? So I'm going to just do a quick drawing. I have a building that is 51 feet tall, and it's casting out a shadow that's 48 feet long. And then I have a statue that we can tell is smaller, that we do not know how tall it is, but we do know that it's casting out a shadow of 16 feet. Now it says, how tall is the statue? Now you might be thinking, oh my goodness, how do I figure this out? There's a key word in here. It says simultaneously. So that's telling us that we can set this up as a proportion because the variables are the same and those ratios have a relationship. The sun is shining on them at the same time, hitting them at the same angle. All those variables are the same. So there's a proportional relationship. If it's causing a shadow on a building a certain length, there's going to be a proportional relationship to that statue. Okay, so we can set this up as a proportion. So it's very easy to do. We have the shadow of the building is 48 feet and it's 51 feet tall. And we're going to say equals the shadow of the statue is 16 feet. And we do not know how tall it is. Now, some of you, as soon as I set this up, you're like, aha, I remember this from middle school. When I have a missing number in a proportion like this, come on, y'all can probably fill it in. It's one of those catchphrases in middle school math. How do we solve this? Cross, multiply, and you can probably fill in that blank, divide. So we are going to cross, multiply, and divide. So I can't cross multiply here because I don't have that digit, but I can cross multiply 16 times 51. So I'm going to quickly do that math. 51 times 16. Hopefully you remember how to do 2-digit by 2-digit multiplication. 6 times 1 is 6. 6 times 5 is 30. Put down your 0. 1 times 1 is 1. 1 times 5 is 5. Add that up really quickly. And we get, sorry, my pen hesitated, 816. Of course, now we get to do the second part of that phrase, which is divide. Ooh, my mouse went a little bit crazy. Hold on. Hold on. I'll be back with you. I bumped it with my elbow. I was so excited about the math. That's my fault. Okay, so now we can set up this division. Now, because you can use a basic 4 function on-screen calculator, I'm just going to pull up my calculator. Of course, you could do this by hand. You could have done the math. To me, that math is pretty easy, so I don't mind doing it by hand. But now I can quickly divide 816 divided by 48. I get 17. So our missing number here is 17. Correct answer is A. Fairly easy math to do once you know to set it up as a proportion. All right, so just remember proportion, cross multiply, and divide. Okay, now let's move on to another one. We have question number 8 here. This one's a little more complicated. It says a rectangular animal pen will be built using 200 meters of fencing. If one side of the rectangle is 600 meters, find the area of the pen. Now, this question could actually fall under several standards, but I'm putting this in here because it's really helpful if you can draw this. So remember when we read that competency where it talked about using scaled models? That's what we're going to basically do here is draw this out. So I know it's asking me to find the area. A rectangular animal pen will be built using 200 meters of fencing. If one side of the rectangle is 600 meters, find the area of the pen. So I know ultimately I'm looking for area. What's the area? And I know it said rectangular pen. To find the area of a rectangle, I simply do length times width. Now, I want to caution you, just don't take the two numbers that are right there in the middle of the question and multiply those, okay? Got to read carefully. It says a rectangular animal pen will be built using 200 meters of fencing. Now, if we're building that pen, that rectangle, my poorly drawn rectangle here, the fence is going to go around the rim. So if it took 200 meters of fencing, we know the perimeter of this rectangle is 200 meters. And then it said if one side is 60 meters. So we have one of these, but we do not have the other side, but we have enough information to figure it out. You don't have to even set this up as an equation. You can just use some basic math knowledge. I know if I have a rectangle and this side is 60, I know the opposite side is also going to be 60 meters. So I know that perimeter means I add all the sides. Add all the sides. So I can add the two that I have. 60 plus 60 is going to give me 120. I don't even need a calculator. 120. So if I want to know these two missing sides, I can take that whole perimeter, 200 minus 120. Hopefully you know this is 80, but if you need to do the math, you absolutely can. You can even use the calculator. All right. So I know this is 80. Now that's 80 for both of these missing sides. It's not 80 each, 80 for both sides. So I need to divide that by 2. And I know 8 divided by 2 is 4 with the 0. So I can bust out the calculator if I needed to. I know both these sides are 40. Now I can quickly do 60 times 40 to get to that area. I can do that on my calculator right here if I want to, or I know that 6 times 4 is 24. And then I have 2 zeros. So if I did 60 pen today times 40, I have 2 zeros and the 24. So I have 2,400. Of course, plug it in the calculator. If that works for you, correct answer here is C. Okay. So really, when I worked through this, I was able to do most of this math in my head. Now you have a calculator, that basic 4-function calculator right there on the screen. I find sometimes it slows me down to actually pull out that calculator. So if you're good with some mental math, you can actually do this pretty quickly. Now I do want to show you, I'm going to see if my eraser pen on this will work. Nope, it's not. Okay, it's going to be finicky today. So I'm going to have to switch this to the eraser old school style. And I just want to make some space. You can, if you asked an upper level math teacher to solve this for you, they're going to set this up as an equation. And so if you're working with someone who does math for a living on a regular basis, they are probably going to set this up as an equation. And I don't want that to freak you out. You absolutely can do this as an equation, but I wanted to show you that you can reason your way through this with basic knowledge of perimeter and area. So if we did set this up with an equation, it would look something like this. We know to find perimeter, we have 2L plus 2W equals 200. And we could plug these in. 216 plus 2, and we still don't know the W. And we can work this equation to solve for W. You absolutely can do that. So if that makes sense to you, go for it. Go for it. But I wanted to show that you can reason your way through some of these tough problems without doing algebra, if that makes some of you feel better. Okay, so we're going to move on to the next question. Classifying 2D figures. Okay. This says, which of the following geometric figures must have perpendicular diagonals? Now, all this question is a knowledge of your vocabulary or an assessment of your knowledge of vocabulary. How many vocabulary words do you know when it comes to geometry? Okay. So I want to show you what this looks like and try to give you some hints to remember these words. So hopefully you remember that perpendicular means I have lines intersecting to form right angles. So the classic example would be two lines intersecting to form four right angles. Although two lines can intersect like this, these are still perpendicular. So the key here is I have to have right angles for them to be perpendicular. So I'm looking for diagonal lines that create right angles. Okay. Now I'm going to give you a quick tutorial on geometric vocabulary. So for two-dimensional shapes, we need to know, well, what is a quadrilateral? What is a parallelogram? What is a rectangle? And what is a rhombus? I like to think of 2D figures like nesting boxes. Did you ever have those as a kid or your parents did this to you at Christmas to torture you a little bit? And it was funny to catch on video where there'd be a big box and you'd open it and there'd be a little box inside, a smaller box inside it. And then you'd open that and then there'd be a smaller box inside that. And then you'd open that and there'd be an even smaller box inside that. I like to think about two-dimensional figures in that way. So I'm going to start with the big box, okay? So I'm going to draw this out for you. I'm going to have to erase it in a minute, but we have this big old giant box, which we will call polygons. And I'm just going to put poly there for the sake of time. All right, polygons. Polygons are two-dimensional closed figures with three or more straight sides. Now we can define it more technically with more math terms, but there's the third grader definition, okay? And what we mean by closed is there can't be an open spot. So this is a closed figure. This is not. It's open right here. You know, something like this is not. It's open. So it's got to have, it has to be closed, and it has to have three or more straight sides. So that's going to take circles out of the equation, ovals out. They're not polygons because their sides are not straight. So polygon, closed two-dimensional figure with three or more straight sides. All right. Within there, now I'm not giving you every one of them, but within there, we can break this down even more. I'm going to do a smaller circle inside here, and I'm going to call this quadrilaterals, and I'm just going to put the Q. Now, quad, hopefully, if you know some basic Spanish, if you watch Dora the Explorer, you can count to 4 in Spanish. Uno, dos, tres, cuatro. Quad should sound similar, means 4, okay? So a quadrilateral is a 4-sided polygon. So that's all this means, that everything that goes inside this box is going to have 4 sides. So while a triangle is a polygon, it would not be inside our quadrilateral box because it only has 3 sides, okay? So a quadrilateral is just a 4-sided polygon. Now we can reduce it down even more, all right? We're gonna get inside there and we're gonna do a parallelogram. All right, so this box is going to be our parallelograms, all right? A parallelogram is a quadrilateral where the opposite sides are parallel. You might be thinking, aren't all 4-sided figures opposite sides parallel? If you don't remember what parallel means, two lines that are equal distance from each other at all points. They run side by side and never cross. There's an elementary shortcut to that definition. Well, there are some quadrilaterals, for instance, trapezoid. And this is the most common way you see trapezoid drawn. These 2 lines right here, yes, they are parallel. But if you extend these 2 lines, they would eventually cross. So a trapezoid would actually go in the quadrilateral box, but not in the parallelograms. All right. So parallelograms, opposite sides are parallel. In there, we can break that down even further. And you're like, oh my goodness. Yes, it just keeps going and going. Now we're going to make 2 circles inside here. We're going to have what we call rhombuses and rectangles. Now I know this is really hard to see, but this would be great for you to draw on your own. Rhombuses, okay? And rectangles. A rhombus is a quadrilateral and a parallelogram, so it's got parallel sides, all right, where all the sides are equal, all right? Now, a rectangle is another type of special parallelogram, and a rectangle is where all the angles are right angles. All the angles are right angles. So it is a special type of parallelogram, all right? And inside the rhombus, our last little square or last little circle box would be square. A square is a special type of rhombus. It's kind of like the rectangle. It has all equal sides like a rhombus, but all the angles are right angles. And you might be like, oh my goodness, that was too much information. But there it is. This would be a great little illustration for you to draw and study and draw some example shapes inside it as you prepare for your exam. Now I'm going to erase most of this business so that it will be easier for you to see. I say I'm going to erase it. Well, let's try that again. There we go, eraser. I'm going to erase a whole bunch of this just so you can see a little bit better. And then I'm going to draw what each of these typically looks like, okay? So that now you're like, okay, she explained it to me. I'm thoroughly confused. Let's see if I can just get my pen back that way. Okay. A quadrilateral is going to be any four-sided figure. So it can look a variety of ways, but I want to draw some of these other ones for you. This is how I used to help my fourth graders out. A parallelogram, my kids would say, usually looked like a slanted rectangle. A slanted rectangle. So the angles aren't right, and that's what makes it a parallelogram. The sides are still parallel, all right, but there are no right angles. A rectangle is going to be that parallelogram stood up straight, as my little fourth graders would have told you, to make right angles. Okay. A rhombus is typically all the sides are the same. Now, I'm not going to be able to draw this right to scale, but I'm going to try. It looks like as my kids would say, a slanted square. So all the sides are equivalent, but there are not right angles. To be a square, my kids would have said, you got to stand that rhombus up straight so that it makes right angles. So now all of that to say, which would have perpendicular diagonals? I'm going to tell you this, right angles will create more right angles. If we try to draw diagonals in these slanted shapes, you're not going to get right angles where they cross. But if I draw diagonal lines where there are right angles, chances get better. So you should be able to narrow this down a little bit at this point, all right? So I'm going to take that parallelogram out of the equation, all right? Quadrilateral, we don't know enough. It's too big of an explanation. So we've got this down to rectangle and rhombus. Now you're probably thinking, ooh, right angles, it's going to create right angles. Draw this and see, okay? I'm going to give you a second to realize why it doesn't make right angles right here to make those perpendicular lines, because all the sides aren't the same length. So in this case, even though we don't have right angles over here, oh, I hope this is making sense. When we cross these lines, because all the sides are the same length, we're actually going to get those right angles, okay? So to get right angles in the middle of these quadrilaterals, everybody hear me this, right angles where the diagonals cross, all the sides are going to need to be the same length. So the correct answer here is rhombus. Had square been an option, square would have also worked. Square would have also worked. Okay, so I hope that helps. It's a whole lot of information. But what's nice is once you know it for one question, we're going to apply it to the next question, okay? Now you know a whole bunch, and you don't need me to teach you near as much. All right, So you see more geometric figures. And the next one has even more geometric figures. So it says select the geometric figure that possesses all of the following characteristics. So it's got to be a quadrilateral, which by now you should know 4 sides. It's got to have diagonals, diagonal lines that bisect each other. Now, if you don't know what bisect means I'm breaking it or I'm crossing it and splitting it into 2 equal parts. Bi means 2. All right. Okay. Everybody with me? All right. So splitting it into 2 equal parts. So when those diagonal lines cross, they're going to split them into 2 equal parts and at least 1 right angle. So we're looking for at least 1 right angle. All right. Now let's go through this. All right. We can quickly rule out, or I hope you're with me, D, triangle, because it does not have 4 sides. It's not a quadrilateral. All the rest of these are quadrilaterals. Now, I'm going to draw them so that you can quickly see. So we have rectangle, and again, I'm sorry, these aren't perfect. Rectangle, and then we have a rhombus, which could be a square or it could be a slanted looking square. I'm trying, guys. And then we have a trapezoid. A trapezoid can actually look several ways. It can look like this. If you look at the definition of trapezoid, it's going to be a quadrilateral with 1 pair of parallel lines. But a trapezoid can also look like this. Okay, so trapezoid can look a couple of different ways. So at least 1 right angle. Now, it didn't say square. So we know in a rhombus, these are not going to be right angles. We can rule out B, rhombus, because if it had a right angle, it would have been called a square, okay? We know rectangles have right angles, yes? And a trapezoid, you're probably thinking of that typical trapezoid. Well, it wouldn't in this case, but if it were drawn like this, it would have a right angle. It might even have more than 1 right angle, okay? So let's look at that last one. Diagonals that bisect each other. So 2 equal parts. So if I take the diagonal lines through that rectangle, now this time I'm not looking for right angles. This would be nice if I had a ruler. But I'm looking for, does it split them into 2 equal parts? So when I draw that, is this part right here equal to this part right here? And is this one bisected where this half is the same length as this half? And the answer is yes. And the reason this works is because opposite sides are the same length. Opposite sides are the same length. With a trapezoid, that may not be the case. So if we draw a diagonal line here and a diagonal line here, oh, I wish I could draw better. The top half, because it's slanting up like that, the top half where they bisect is going to be smaller than the bottom half of that diagonal line. And the same thing over here. If I draw diagonal lines through this trapezoid, you can see this half right here of this line is definitely smaller than this half. So we can rule out trapezoid, and the correct answer is A. So I hope that helps and that makes sense. We're going to look at a couple of more before we run out of time. So this one says, which of the following best describes the faces of the following figure? Okay, so here's where you have to understand some basic terms. It's talking about equilateral triangles, isosceles triangles, squares, and rectangles. We've already talked about rectangles. You should know what those are. So let's talk about equilateral triangles and isosceles triangles. So an equilateral triangle is a triangle in which all 3 sides are the same length or equal. All 3 sides are equal. That's an equilateral triangle. An isosceles triangle is where 2 of the sides are equal. Now, typically, when people think of isosceles triangle, they think of a triangle like this, where those 2 pieces up here are equal, but this one is different, okay? Equilateral, all 3 are equal. Now, I want to point out that you can have an isosceles right triangle. So basically, that would be a triangle with a right angle where A and B are equal. Where A and B are equal, where these two are equal, and our hypotenuse, or the other side, the long side, is different. Okay, so this would be considered an isosceles right triangle. All right, so once you know that, you can reason your way through this question. So it says two equilateral triangles. Well, I can see my triangles exist right here. All right. Now, most of you can see we've got 45 degree angles. If you know anything about triangles, what do they have to add up to? 180 degrees. So that tells us this angle is a right angle. If I had 45 and 45, I'm going to get 90. 180 minus 90 is 90. So this angle has to be 90 degrees. So that tells us this cannot be an equilateral triangle. It can't be an equilateral triangle. So that can actually rule out A and B. Now you got a 50-50 shot of getting it right, even if you don't think through anything else. Now you might be thinking, how do I know this side is different? Because these two angles are here, and we know we have this right angle right here. This side's going to be longer. It's going to be that same right triangle you're used to seeing, where that third side is longer. And hopefully you can visually see that as well. Isosceles triangles, two isosceles. Now it's a right isosceles, but we know that because these angles are the same, then A and B are the same length. A and B are the same length. So if you've got those equivalent angles, all right, A and B are going to be the same length. So A and B are the same length. So that's why it is isosceles. So now we got to figure out all the square and rectangle business. Now, most of you are probably thinking, okay, I can see right here. Let's see if I can draw that a little bit better. I have a rectangle. I have a rectangle. And I know on this side, I'm going to have the opposite triangle. But what I've got to figure out is what's on the back and what's on the bottom. So I know I'm going to have at least one rectangle. Now it's just a matter of, are there two rectangles or are there two squares? Now I'm going to try to erase just to make that a little bit easier to see. I'll turn my pen back on. Okay. Now we've got to look at that back. Well, we know down here, the bottom piece, two of its sides are A. They're both labeled A, so they would have to be the same length. They would have to be the same length. Since those two adjacent sides are both labeled as A, we know all the sides. It can't be a rectangle because the adjacent sides, if it were a rectangle, would not be the same length. They would both be labeled A. So the bottom piece has to be a square. So that piece that would be on the bottom of this shape, I just drew that poorly, would be a square. So we know we have at least one square and one rectangle. Now the back piece, all right, the back, we already said that A and B were the same. Now, if this bottom piece is a square, then we can label all of the sides A, which means the back piece back here in the back standing up that we can't see, that's terrible drawing, terrible drawing. We already know this side is B, and this side that makes up that bottom square, this side right in here that you can't see, if we could draw this three-dimensionally, it'd be a little bit better. Okay, we already know all these sides are A, and A and B we already know are equal. So that if these two adjacent sides are equal, all the sides are going to be equal. So this back piece is also a square. Bottom's a square, back piece is a square. So we have two squares and one rectangle. So the correct answer here is D. Now, I talked that out and made it sound really long, but when you reason through all that in your head, it actually goes much faster. All right. Last two questions, and I have them up here together because they're so similar. This is basic units of measurement. Do you know basic units of measurement? So it says, which of the following is the best estimate for the height of a kitchen refrigerator? Okay, now I'm gonna give you some hints. All right, we're talking about meters and we're breaking that down into different increments. A millimeter, I'm gonna give you a reference point, is about the width of a pencil lead, or the smallest, the teeny tiny lines on a ruler. All right, that is the smallest increment. So I want you to picture the height of a kitchen refrigerator. Would it be 2 little pencil leads? No, way too small. A centimeter, a good rule of thumb is, we'll call it rule of pinky, is about the width of your pinky fingernail. So if you hold up your pinky fingernail, even if you don't have much of a nail, look at the part you do have, that's usually about a centimeter. That's a good reference point. Well, 2 of those certainly wouldn't be the height of a kitchen refrigerator. Now, meter, hopefully you can remember a meter stick. You saw one of those in school at some point. If I put 2 of those on top of each other, would that be about the height of a refrigerator? Yeah, maybe. So I'm gonna put a little dot by that one. 2 kilometers. Now, if you're thinking, I have no idea how long a kilometer is, guys, think of a 5K race. Well, if a 5K, if a kilometer was short enough to measure a refrigerator, that'd be a really short race. That'd be like running from one room of your house to the other and saying, I ran a 5K. So kilometers much longer. In fact, it's very comparable to a mile. A 5K equals 3.1 miles. So this is too much. Correct answer here is C. The next one's very similar. Which is the following of the best estimate for the height of a mountain? Mountain, folks. Mountain. Tall. Well, it's certainly not going to be centimeter. Again, pinky fingernail. Not 4 of those. 4 meter sticks. I don't think we'd call it a mountain if it was only that tall. 4 kilometers, 4 miles, not quite 4, or yeah, be less than 4 miles. So that's about like running a 5K. That sounds reasonable. 4 millimeters for pencil leads? No. Only reasonable answer here is C. Now, I want to point out something to you that might help you with these types of questions, okay? I want you to remember the progression in the metric system, all right? So I'm going to put the units right here in the middle, and that's going to be either liter or gram. Meter, liter, or gram, okay? And then we can work our way down to smaller units or up to larger units. And if nothing else, remember that milli is tiny and it's on the very end. It's the smallest, all right? And kilo is at this end and it's the largest, okay? Most people can usually remember that right before, after milli, we get centi or centimeter, centi, however you want to say it. In between there, this is the one that most people can't remember, is decimeter or deciliter. All right, so you have milli, centi, deci. And then if you go up this way, the 2 nobody remembers, I mean, if we're just being honest, is deca and hecto. If you can just draw that and memorize it, you'll be able to quickly answer all of these questions. All right, quickly. You also have a mathematics reference sheet that kind of gives these questions away, and we'll take a look at that in just a second, okay? So that was the end of our questions. I want to remind you, know your test format, how many questions there are, what are my time limits, so I know how many I need to get right and how many I have to move through to get to that possible number that I need. Familiarize yourself with what the screen looks like. You can do some practice. I have that link right here. You can Google it and find it. Practice using that on-screen 4-function calculator, or at least the very basic calculator on your phone. Don't turn it sideways and get all those extra functions, or invest in the calculator that looks like the 4-function calculator. And then there's the reference sheet. This reference sheet can actually come in very handy. In next week's video, when we look at that last skill in this competency, you're going to see just how powerful that reference sheet is. Okay. So practice not only your questions, but your pacing, how quickly you work through them. I want to point out down here, conversions. It's showing you a whole lot of things here. It says, notice this right here, 1 meter equals 100 centimeters equals 1,000 millimeters. So if you just remember meter stick, you can now see centimeter and millimeter are much smaller than that. So even if you can't remember it, you have this mathematics chart to point that out to you. So I practiced using this mathematics chart. All right. Now, if you want more information, I'm 10 minutes over my 30 minutes, but this was so much fun. I would encourage you to check out our study guides and keep joining us in our Facebook groups. I'll be here every Tuesday, but they are also going to be in a playlist on our YouTube channel. So if you're more of a YouTube person, go check that out. Again, we have free resources and our study guides if you need more material to help you out. I wish you all the best, and I look forward to seeing you next week. Again, I'm Dr. Christy Mulkey with 240 Tutoring.